Hello, welcome everyone. So today we are going to start with the logarithms and the questions based on the properties of logarithms. So basically logarithms are of two types in maths. First is common log and the second one is natural log. But here in maths we are going to study about common logs only, and common log is basically with base 10, and natural logs are basically with base e, right? And here the representation of this one common log is log of x with base 10, and the representation of natural log is log of x with base e, or you can say ln x. This is also one of the notations. And if the base is not given in a question, so the base will consider to be 10 only. That means it will be a common log, right? So we are going to learn mostly about this common logarithm only. So now let's talk about some of the properties here. So suppose there is a number a raised to power n equal to b, then you can write this term in forms of log, which is log b with base a is equal to n. So basically the base here becomes the base of log here, and the answer that was here becomes the function of log here, and this power becomes the answer of the log, right? So this will, according to this, let us say we have an example. Suppose we have 10 square equal to 100. So if we want to write it into logs, so it will be log 100 with base 10 is equal to 2, right? Suppose we have another example. Suppose we have 2 raised to power 5 is equal to 32. So you can write down log of 32 with base 2 is equal to 5, right? So this is how we can write down the uh, any form of a power into the form of logs, right? So a few things to remember here. First is log 1 with any base a is equal to 0. It is always 0. A can be any value. And log of a with base a, which means that this value and the base becomes the same, it will become equal to 1. For example, log 10 with base 10 is equal to 1. Similarly, log 1 with base 1 is equal to 1. Log 2 with base 2 is equal to 1. So this is how log a with base a becomes 1, right? Then similarly, what we have is, third one is log x with base a is equal to log y with base a. If the bases are same and the values here given in this log are different, then these values will also be equal by comparing. So x will also be equal to b, right? So this is how we have to go for these. So now let's do some of the question based on these properties. For example, let us say we have a question here. log of 32 with base 2 is equal to 5, and we have to convert it into the exponential form. So what we can do is the base becomes the base 2, and this answer, this 5 becomes the power of this, and the answer will be 32. This is how we have to write it, right? Another question is, suppose we have log of uh, 0.25 with base 2 is equal to -2. So what we have to do is the base becomes the base again, and the power becomes this -2 here. 2 raised to power -2 becomes 0.25. So this is how we have to write it in the exponential form, right? Then after that, if we want to find out the value, suppose we have another type of question. For example, we have log of 16 with base 2. So what we have to do in these type of question, if we want to find out the values, we have to convert this 16 in terms of 2. So we know that it is equal to 2 raised to power 4, right? And there is one property which says that if we have log of a raised to power x with base a, then its value will be x, which is log a with base a, and log a with base a, which is equal to 1, so the answer will be x. And according to this property, its answer will be 4 log 2 with base 2, and log 2 with base 2 will be 1, so the answer will be 4 here, right? I hope it's clear. Similarly, suppose we have another question, log of 8 with base 4. So what we have to do to find its value, we have to let it equal to x. And if we write it in that way, in the exponential form, so it will be 4 raised to power x is equal to 8, right? And now we can convert both the numbers in the powers of 2. So 2 raised to power 2 whole raised to power x is equal to 2 raised to power 3. So 2 raised to power 2x is equal to 2 raised to power 3. And by comparing, if the bases are same, then the powers will also be equal. So x will be equal to 3 by 2. And this will be your answer, right? Similarly, if we want to find the value of x, this is another type of question which we have here. Suppose we have log of x with base 10 is equal to -2. So first of all, we have to convert it into exponential form, which will be 10 raised to power -2 is equal to x. So just we have to now just solve it. X will be equal to 10 raised to power -2. And if you want to convert it into positive powers, so it will be 1 upon 10 raised to power 2. We have to reciprocal it, and this will be 1 upon 100. So the value of x will be 1 upon 100 here, right? Then the next question is log of x square minus 1 with base 2 is equal to 3. Suppose this is the question and you have to find out the value of x here. So if we convert it into the exponential form, it will be 2 raised to power 3 is equal to x square minus 1. And we know that 2 raised to power 3 is 8 plus 1 equal to x square, right? We have taken this -1 to the left hand side. So it will become uh, x square is equal to 9. And we know that 9 is 3 square and this is x square. So therefore, because the powers are equal and the bases are different. So by comparing, we can say that x will be equal to 3. The bases will also be equal, right? All these things we have learned in exponents and powers, the video before this. Similarly, suppose we have another question, log of x plus 1 with base root 3 is equal to 2. So now we have to convert it into exponential form. So it will be root 3 raised to power 2 is equal to x plus 1. Root 3 square will become 3 is equal to x plus 1. And if we take this x1 to the left hand side, it will become 3 minus 1 equal to x. So x will be equal to 2. And this will be the answer. I hope it's clear to you. So now let's move to the properties. Properties of logarithm. So the properties are, the first property is log of mn. If two numbers are in multiplication, then it will be log m plus log n, right? We can just split it into two parts and we can take log of both of these numbers and add them. Similarly, if two numbers are in division, then it will be written as log of m minus log of n. Similarly, if there is a number m raised to power n, then this n, the power will come in front and this will be n log m. And this is one of the most important properties. Fourth property is, suppose we have log of a raised to power b, sorry, log of a with base b, and you want to convert it into a common logarithm, which means with base 10. So what we have to do is we have to do log a upon log b. If the base is not given to you, then it means that the base is 10 only, right? So we don't write 10 here all the time. It only mean that all these logs have base 10 here because it is the common logarithm, right? So if you want to convert the base of the logarithm, then you have to take log b, which means the base which was given to you, you have to take its log and keep it in the denominator, right? Then suppose you have log of a raised to power x with base a, then the answer will be x only because log a with base a becomes 1, right? Then a raised to power log of x with base a also becomes x. And so these are the properties which we can use to find out the answers. So let's do a few questions from. So the question 1 is, suppose you want to find out the answer for log of a cube minus log of a square. So I told you that according to the formula or the law, the powers will come in front. So it will be 3 log a minus this will be 2 log a. And since log a are common here, log a will act as the variables only. So it will be 3x minus 2x, you can say. And 3x minus 2x is x only. So the answer will be log a, right? Then another question is, suppose you want to find out log of 27 divided by log of root 3. So now because these logs are in division, so what we need to do is we need to convert them into the powers of 3, because both can be converted in the powers of 3 easily. So 27 can be written as 3 raised to power 3, and root 3 can be written as 3 raised to power 1 by 2. And this will be 3 log 3 upon 1 by 2 log 3. And here log 3 is common, so it will get cancelled. And this 2 will come to the numerator, so it will become 3 into 2, which is equal to 6. And this will be the answer. Now, the next question. Suppose we have 2 log 10 cube plus 3 log 10 raised to power minus 2 minus 1 by 3 log 5 raised to power minus 3 and plus 1 by 2 log 4. Suppose this is the question. So I told you that the powers will come in front here. So 2 into 3 log 10 plus 3 into minus 2 log 10 minus 1 by 3 into minus 3 log 5 plus 1 by 2 log 4 can be written as 2 square. So here it will become 6 log 10, or this will become minus 6 log 10. This will be 3 will cancel out each other and minus minus becomes plus. So it will be log 5 here plus 2 upon 2 log 2. So this also gets cancelled. This will also get cancelled. 6 log 10 minus 6 log 10 becomes 0. And we are now having log 5 minus log 2. And I told you, according to the standard law, log a plus log b becomes log a into b. So it will be 5 into 2 here, which is log 10. And I also told you that if the base is not given, then the base is always 10, because it's the common logarithm. And log a with base a, if the base and the number here is same, then the answer will be 1. So log 10 is always 1, right? Okay, similarly, we have another question. Suppose we have 2 log 2 plus log 5 minus half log 36 minus log 1 by 30. So here what we have to do is we have to solve the equation here. So all these terms which we have, because nothing is getting cancelled here, so what we have to do is we have to take the numbers in front to the powers. So it will become log 2 raised to power 2 plus log 5 minus log 36 raised to power 1 by 2 minus log 1 by 30. So this will become log 4 plus log 5 minus 136 root will become 6 here, and this will become 1 by 30 here. And now applying the property, those which are in addition will go to the multiplication part, and which are in subtraction will go in the denominator. So this will be 6 into 1 by 30. So 6 5s are 30, and this 5 will come to the numerator again. So it will be log of 4 into 5 into 5, and that will be equal to how much? Log of 100. And log of 100 can be written as 10 raised to power 2. log 10 raised to power 2, which is 2 log 10, and I told you that log 10 is 1 only. So 2 will be the answer, right? So this is how we have to do these questions. Similarly, we have another type of question we have. Suppose we want to convert the following into a single logarithm, then this is 2 log 3 minus half log 16 plus log of 12. Again, you have to do the same thing. You have to take these to the powers of, so it will become 3 square minus log of 16 raised to power 1 by 2 plus log of 12, right? So this will become log of 9 minus log of 4, because 16 root is 4, and plus log 12. And now this will become 9 into 12 upon 4, and this 4 will cancel it. Those numbers which are in negative will come to the denominator, and those which are in addition will come to the numerator. So 4 threes are 12 and 9 threes are 27. So it will become log 27, and we can write 27 as 3 raised to power 3, and this will be 3 log 3 according to the law, right? So this is how we can convert it into a single log. Then after that, we have another type of question where we are given with x is equal to 100 raised to power a, y is equal to 10,000 raised to power b, and z is equal to 10 raised to power c. Right. So what we have to do here is we have to actually find out, uh, we have to express this term log of 10 under root y upon x square z cube in terms of a, b, and c. So what we have to do is we have to separate all of these. So this will become log 10 plus log of root y minus log of x square minus log of z cube according to the law. Log 10 is 1 obviously. Then root y, because its power is 1 by 2, so it will be 1 by 2 log, and the value of y is 10,000 raised to power b minus log of 100. This 2 will come here, and it is 100. The value of x is 100 raised to power a, minus 3 will come in front, and log of 10 raised to power c. So this will be b will also come here, so it will be b by 2, and this is 10 raised to power 4 minus 2a 10 square minus 3c log 10. So 1 plus 4b upon 2, and the remaining is log 10, which is equal to 1. Then again 4a into 1, because log 10 is 1, and 3c, which is log 10, which is 1 again. So here you will find the answer as 1 plus 2b minus 4a minus 3c. And this is how we can convert it into the form of a, b, and c by simply applying the laws of logarithms. Similarly, we have another question. 3 into log 5 minus log 3 bracket close minus log 5 minus 2 log 6 is equal to 2 minus log n, and we have to find the value of n here, right? So what we have to do here is, this can be written as log of 5 upon 3 minus, this can be written as log of 5 minus log of 6 square is equal to 2 minus log n. So this will be log of 5 by 3 minus log of 5 upon 6 square, which is 36, 2 minus log of n. And if we take this 3 to the powers of 5 by 3, it will become 125 upon 27 minus log of 5 upon 36 is equal to 2 minus log of n. And log of a minus log of b becomes log of a divided by b. So it will be 125 upon 27 divided by 5 upon 36. So it will be equal to 2 minus log of n. And here it will become log of 125 upon 27 multiplied by 20 36 upon 5. So 5 will cancel here, this will be 25, and this can be cancelled with 3. 3 18s, 3 12s are 36, and 3 9s are 27. And again with 3. So 3 4s are 12, and 3 3s are 9, which is also equal to 2 minus log n. So now this becomes log of 100 upon 3 is equal to 2, because 2 is a single term. So if we want to convert it into log, it can be written as log 10, because log 10 is always 1, and minus log n, and this can be written as log of 10 square upon n, which is equal to log of 100 by 3. And since the logs are same, so by comparing, 100 upon 3 should be equal to 100 upon n. So this 100 will get cancelled, and the answer of n will be equal to 3 here. Right, so this is how we have to find the values here. Then we have another type of question where log of x minus y upon 2 is equal to half of log x plus log y, and we have to prove that x square plus y square is equal to 6xy. This we have to prove. Now what we have to do is, see, we have to compare them. So we have to take this 1 by 2 log of x plus log y can be written as log of x into y. And if this half will come to the power of this, so it will be log of x minus y is equal to log of under root xy. Right, now the logs are same. So by comparing x minus y by 2 will be equal to x root xy. And now if we compare them, means if we have already compared them, so now we have to square both the sides to uh, remove this square root. So squaring both sides, we will get x minus y whole square divided by 4 equal to xy. Now x square plus y square minus 2xy is equal to 4xy, and this 2xy will go to the other side. So x square plus y square becomes 4xy plus 2xy, and therefore it will becomes 6xy. And this is how we have proved that x square plus y square is equal to 6xy, right? So these are a few questions based on the properties. In the next video, we are going to learn about trigonometric tables, how to see the not trigonometric, logarithmic tables and non anti-logarithmic tables, right? So this is it for today.